The next one we're going to learn is for 30, 60, 90-degree triangles. The length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is radical 3 times the length of the shorter leg. So there's 2 different formulas we're using for a 30, 60, 90-degree triangle. Let's practice this. In this example, what's the value of d in simplest radical form? Again, this is what we've just learned for a 30, 60, 90-degree triangle. So we're looking for d, which is the shortest side of this triangle. We're looking for d, and the longest side of the triangle is given. So we're not dealing with the hypotenuse, which is across. So we don't need this first one because we're not working with the hypotenuse. So looking at the second one, the longer leg is 5. So let's write 5 here. 5 equals radical 3 times the shortest leg, and the shortest leg is our d. That's what we're looking for. So if I rewrite that, 5 is equal to d radical 3. To solve for d, we have to divide both sides by radical 3. This cancels out. Radical 3 divided by radical 3 is 1, so just d. And now we have 5 divided by radical 3. So just like we learned before, we cannot have a radical as the denominator. So the value is not in simplest radical form because there's a radical there. So multiply the denominator by a form of 1. Let's try that again. So we have 5 radical 3, and we'll be multiplied by radical 3 over radical 3, which is a form of 1. Multiplying the numerators, 5 times radical 3 is 5 radical 3. And radical 3 times radical 3 is simply 3. So our d is equal to 5 radical 3 over 3. Next example. An artisan makes pendants in the shape of equilateral triangles. So let's remember this is an equilateral triangle. The height of each pendant is 18 millimeters. What's the length of each side of a pendant to the nearest tenth of a millimeter? So 18 is given, and we can see 18 here is the longer leg. So we're not going to use the first equation. We're going to use the second one, the one with the longer leg. So let's substitute the values. Longer leg, 18 millimeters. So 18 equals radical 3 times the shorter leg. Well, here's the shorter leg. Because we know this is an equilateral triangle, we know this has to be half of length s. So we will do radical 3 times 1/2 of length s. Let's simplify. 18 equals, multiplying straight across, radical 3 times 1 is radical 3, so radical 3 over 2s. Here we're solving for s, so we need to divide both sides of the equation by radical 3 over 2. And the way we do that is by multiplying it by the reciprocal. So that would be 18 times the reciprocal, which is 2 over radical 3, is equal to s. Now multiplying straight across, putting 18 over 1. 18 times 2 is 36. 1 times radical 3 is radical 3. And that is equal to the side of the pendant. So to solve this, you would put in the numbers in your calculator, and you would get s is equal to 20.78446. Therefore, each side of the pendant is about 20.8 millimeters long, rounded to the nearest tenth.